Well, if you like mining, Mining Now is a show to watch, and we are doing a ton of episodes, part of our heavy industry world tour. That includes Australia. We were just in South Africa. Well, actually, no, first we were in Vancouver, then South Africa. Now we're in Australia at IMARC, which is a great event, a lot of technology at that event specifically. And we want to thank Savanna Equipment for helping us do this world tour, helping us get all over the world to do it, and our team for being there. Next, coming up on the show will be we're going to be at Indaba. That's going to be in Cape Town, South Africa. So that's February 6th to 9th. We're also going to be at Power Gen on the Crownsman Show, February 21st to 23rd. So if you want to join us for either one of those events, make sure to let our team know and we can book you in for an episode. Okay. We are going to have on this episode a great company, Dotmar Engineering Plastics. We're going to have Aldo Mustachi. He is the technical marketing engineering manager at Dotmar. Well, I don't know why I'm stumbling on that. And then I hope I'm saying his name right. We're going to have two guests today. John Roden. I'll get Aldo to correct me. He's the project manager at Dotmar. So lots to cover. They're doing some very interesting stuff, and the first guest of this type, this product line, on the show. So very exciting. Aldo, welcome to the show. Great to have you on.
Uh,
How bad did I butcher John's name?
yeah, a little.
A little.
It's John Reeden.
Reedon. It's not even hard.
Reed.
I don't know what happens. I get sometimes when you do this, but I think we're doing 15 episodes or 16 in the period of 7 days for our Australian leg, and a name sometimes just catches your brain. You can't fix it. I don't know what it is. But anyway, thank you very much for being on the show. Looking forward to it. So Aldo, I'd like to just first understand who the company is. I didn't book Dotmar on the show, Dennis did, and so I'm just sort of learning about it with the audience. Can you just tell us who the company is?
Yeah, so Dotmar, we're an engineering plastic business. So what that means is because the plastics industry is quite wide and varied. So there's
Mm-hmm.
molding, thermoforming, but we deal mainly with engineering and industrial plastics. So what we do is we have materials in rod and sheet form. And when we talk about rod and sheet, rod from 5 mil diameter right up to 500 mil diameter, sheet from maybe 1 millimeter thick right up to 100 millimeter thick. And then what we do is we actually custom machine that into finished parts. You can see some parts behind me with some gears and bits and pieces there. So we'll machine that on CNC equipment, so traditional metalworking type of equipment. And so they're all custom made to customer specifications. We don't make products; we make parts, and they'll go into bits of machinery in all industries. We have a big focus for the mining industry, but we do deal in other industries as well. Been around for about 50 odd years, or a bit over since 1967. And maybe a little bit of trivia for the audience of the name Dotmar and where it came from. It's actually after the original owners, mother and son combination of Dorothy and Mark Bingham. So that's how the name Dotmar came about.
So what's the main market then? Where's your reach?
We, as far as location, we mainly deal with Australia and New Zealand. So cause we've got 5 operations in Australia and 3 in New Zealand. So we mainly deal with Australia and New Zealand. A few surrounding countries as well. We support some of the smaller countries around our region, but it's mainly Australia and New Zealand at the moment.
So the plastics industry, it's such a vast one. Sort of what are those, and we'll obviously talk about the mining specifically, but what sectors, what's kind of across the board, what sectors are you serving?
We actually serve quite a lot of different sectors. I mean, apart from mining, the rail industry, both rail wagons and track work, food industry, so food packaging. We don't do the packaging, but the food processing, so the equipment to process food like conveyors, filling lines, packaging lines, all that equipment uses engineering plastics as either generally wear components or conveyor type of components. We make gears and sprockets, bearings, rollers, bushers. But really, any industry that has mechanical equipment often uses engineering plastics. Even the medical industry, it's it's actually much easier to say which industries we don't deal with, and I
Right.
can't
Yeah,
actually
that's
think of
probably
one
would have
off
been a
the
better
top of my
question.
head right now.
Yeah.
Yeah.
Geograph is Australia's leading manufacturer of enhanced performance mining parts. Geograph designs and manufactures enhanced wear parts to suit major mining machinery from Caterpillar, Komatsu, Hitachi, Liebherr, and more. The Geograph Enhanced Performance range is designed to reduce downtime and operating costs for mine sites and off-site repairers by engineering wear parts to last longer. Geograph challenges you to expect more from yourself and your assets. Visit geograph.com.au for more information or click the link in the video description below. In business since 1960, Dcor is a leading private manufacturer and distributor of specialty chemicals, equipment, parts, and accessories serving the energy and mining industries. Dcor manufactures and distributes a full line of drillers' edge coring rods, core retrieval systems, and diamond tooling for diamond core drilling worldwide. They also manufacture and sell high-quality Earth Pro drilling fluids and additives for the mineral exploration and energy industries. For more, you can visit them at die-corp.com or contact their head office at 780-440-4923. Okay, so let's give a special thank you to one of our longest sponsors of the show, Savanna Equipment. And I'm actually going to hand it over to Jared so that he can give you a little bit more info on Savanna Equipment.
Yeah, thank you. So I mean, people see them as sponsors, so they'll ask me, kind of who they are, what they are, and just trying to understand the scope of the company. So Savanna Equipment is a mining supply company, and they're delivering on the whole equipment supply chain. So everything from the ore processing to underground mining, open pit. They're in hard rock and placer operations. And what they're doing is they're sourcing equipment from all over the world and then delivering it all over the world. Now, they are a Canadian company, so they're based there, but, let's say, they're selling entire ore processing plants. So there might be a plant down in Latin America, and there's a new mine that needs that plant in Africa or somewhere in the U.S., so they're facilitating that entire transactions. But they're also delivering, an individual conveyor or a concentrator or a pump package or just an electrical package. So it really is the whole gambit of the mining equipment supply chain.
Oh, that's great then. Well, then you definitely have to check them out. If you're looking for mining equipment, visit them at savannaequipment.com where you will find more equipment every day.
So are you dealing with the so are you dealing with both end users and OEMs then?
Yeah, absolutely. So we do OEMs, so manufacturers of equipment, often need components made for their machinery. So we will manufacture for them as well. But also end users, they'll need replacement parts.
Yeah.
And that could be, for example, in the food industry, if they've got a conveyor which is transporting bottles or containers, they'll have wear parts or under-train wear strips, which periodically need to be replaced. And in the mining industry specifically, obviously, a lot of wear applications, abrasive situations. And so plastic materials are often used in those sorts of applications. Maybe it's easier to explain why plastics are used than so much where they're used. A lot of areas of wear and abrasion, where for bearings and bushers, wear pads, but also we want lightweight materials, chemical resistant materials as well.
Right, yeah.
So,
that must be in like
storage.
mining. Is that a big sector for the mining side, like the chemical resistant materials?
Absolutely, yeah. Chemical storage
Right.
tanks is a big thing, and that's actually a big industry here in Australia, where because mining is quite large, the fabrication industry uses our materials to manufacture tanks. We're actually going through a process right now with Standards Australia where we're updating the standards so that tank manufacturers have got a guide to manufacture to. So we're actually implementing some standards from Germany, the DVS, which has been voluntarily adopted for the last 12 or 13 years, but very shortly should be gazetted into the Australian standards.
So when you say a standard, this is like a government regulation standard type thing?
Yeah, absolutely. So there's guidelines on how components and tanks need to be made,
Right.
what materials can be used, what are the design practices to make sure that they're safe. You can imagine if you're holding, you've got a 5,000 litre tank holding hydrochloric acid or sulfuric acid. You want to make sure that thing ain't going to burst and spill dangerous chemicals everywhere. So we need to make sure that they're designed to an appropriate standard, so they're safe and survive their design lifetime.
Founded in 1989 in South Africa, the Bloemburton Engineering Group is a world leader in ventilation, refrigeration, and cooling systems for underground mines. BBE Consulting Canada, created in Greater Sudbury, Ontario, is part of the BBE Group of companies since 2016. Its services include mine ventilation and cooling system modeling, feasibility studies, detailed engineering, procurement and construction management, as well as site ventilation surveys, ventilation audits, and training mentoring for underground mines across all Americas. You can reach out to BBE Consulting Canada by visiting bbegroup.ca or writing to enquiries@bbegroup.ca. Also, watch out for BBE's upcoming episode on mining now. CIM is the leading membership organization for technical content and creating connections in the mining industry. Mining professionals and students can access a breadth of technical expertise through the CIM Technical Paper Library, the WineMine Digital Repository, the CIM Journal, the CIM Magazine, and attend upcoming CIM webinars. Whether you're working in the field, in the office, or at home, join the community today and learn how they can help you achieve your professional goals. Visit them at cim.org. Fender Dunlop Usflex belts are engineered to withstand the harshest applications, delivering benefits that solve customer problems via superior rip, tear, and impact resistance. Usflex are extremely strong and robust belts that are difficult to destroy, which is important for heavy-duty bulk material handling environments. Made in their very own North American manufacturing facilities, this revolutionary concept in straight warp conveyor belting is up to 3 times more impact resistant versus competitor belting. Usflex users use fewer belts per year, make fewer belt repairs and replacements, reduce or eliminate belt downtime, and improve employee safety. You can visit FenderDunlopAmericas.com to learn more about their premium Usflex conveyor belting.
I was you're talking, something that came to mind was the technical support, because if you're doing a lot of wear parts, we've had some quite interesting companies, that are supplying like lubricant services, or like even a bolting company that was on, which people just love that episode because it's a thing that doesn't get talked about as much. And I feel like your company would be a similar thing, that you can miss it as such a key part of the operation. So are you providing, is there a technical aspect? Do people sort of order on, or is there some sort of layers of support in all these wear parts? I'm thinking especially in the mining sector, remote areas and all that.
Yeah, absolutely. I suppose, these days you need to provide technical support for your products. And so absolutely, we're not a design or consultant house, but we do provide technical support. We have qualified engineers in the business, including myself. I'm a qualified mechanical engineer. So when, let's say, just for the mining industry, if they're going to be using our materials in wear applications, they need to understand and have information on the capabilities. So we'll do testing on our materials and have that data available. So wear test, so what sort of abrasion properties they've got, but then providing advice, but also even doing load calculations as well. So they may say, look, we've got a crane on site which is holding, it might be a 100-ton load, and they might be using an outrigger pad foot, and they need to know, can the plastic take those sorts of loads? So we'll do those calculations for customers and let them know, if the material is capable of withstanding those loads, and also how close we are to the limit, so they know what sort of safety factors. And that's important because engineering plastics, it is a real engineering material, but a lot of engineers out there, when they're at universities, aren't trained in plastics. They're generally trained in more traditional engineering materials like metals. They don't have an understanding of their capabilities. So we need to be able to provide that so that they can safely design materials and components into their equipment.
I almost feel embarrassed to even ask this, but how do you does mining have different plastics that they are consistently within the industry? I mean, I'm assuming one plastic is not like the other, of course, but I don't really have the understanding to sort of more intelligently ask that. So I'll ask the layman question of, is like you hear words like polymers and things like that. Can you sort of outline some of the key, I guess the actual product, it's the raw product itself that's typically used in the mining operations?
Yeah, look, typically we use, for the mining industry, so we have engineering plastics fall into a bunch of different areas. You've got sort of the industrial, then engineering, then high performance materials. And in the mining industry, generally they tend to fall mainly in that middle ground of engineering materials. So one of the most common materials would be polyethylene, and which has very good abrasion resistance. It's actually one of the most abrasion resistant materials that we've got. And so it can withstand sand and slurry rubbing over it all day, every day. So for lining of hoppers, which John, my colleague, will talk extensively about. But then also other typical materials would be nylons as well, that can be used for cranes and drag line components. So wire rope sheaves on cranes and drag lines are commonly used, and actually replace metals because they're significantly lighter, only a 1/7 of the weight, but also have better wear properties when you have a wire rope running over them. So sheaves will last in the order of a couple of twice as long as a metal wire rope sheave, but more importantly, the actual wire rope running on it can last anywhere between 2 to 6 times longer than when running against a metal sheave, like an SG iron sheave or some other cast material. Other typical materials would be polypropylene, that is used for chemical vessels. Both polypropylene and polyethylene can be used for chemical vessels because they've got fantastic chemical resistance. For example, hydrochloric acid that will eat through metal, polypropylene is an ideal material to manufacture a storage tank for hydrochloric acid, because it can withstand that far better than metals. Metals will eat away and you'll end up having a big hole in the side of your tank, where polypropylene can withstand those chemicals all day, every day.
And what, again, very much a layman question, but what is the material? Is it the composition of the material? What makes one so much more wear resistant than the other? Is it sort of, I mean, I guess like steel, you're, like a samurai sword, you're folding it over and over. I'm assuming it's not something like that. I really don't, I'm not a plastic expert, so I'm really asking a basic question. But
yeah, it's no, hey, great question. So for example, polyethylenes, well, polymers are made up of polymer chains, so to speak, and actually think of it like at a microscopic level, like a bowl of spaghetti, that you put into, the fridge when you have leftover spaghetti, you put it in the fridge and you pack it into a container. When you pull it out the next day, and you can see all the spaghetti strands, that's what a polymer looks like effectively at a microscopic level. And when a material wears out, it's actually you're pulling out those polymer chains one by one, and the longer those polymer chains, the better the wear and abrasion resistance of that material is. And polyethylene is a classic example. You can have very low grades of polyethylene, and as low as candle wax is a very low grade of polyethylene, right up until ultra high molecular weight polyethylene, which can have what we call, the way we describe polymer chain length is by the molecular weight of the material. And traditionally, the most common molecular weight might be about 5 to 6 million grams per mole, but we have materials that go right up to 9.2, even to 10 million grams per mole, and you get far higher wear resistance because those polymer chains are so much longer that it's harder to pull them out of the matrix. Therefore, the material doesn't wear out as quickly because it's so much harder to remove those polymer chains. So effectively just lasts longer compared to if you have very short polymer chains. And again, I'll go back to my bowl of spaghetti analogy. If it's when you cut up spaghetti into little pieces like you do for your kids, you can imagine that each of those short strands can pull out quite easily compared to when it's long strands and it's solidified or cold. It's in a block once you've left it in the fridge overnight. Those long chains are hard to pull out as full chain. Sure, you can break the spaghetti strand, but in plastics, you can't easily break those chains because they've got covalent bonds, and that's very, very strong. So you're literally pulling out one chain at a time. So when you do have longer polymer chains, then you have better wear resistant materials. And that's where really our industry operates. We operate high-end materials. And you can get cheaper and lower end materials, and they're great. but when it comes to wear and abrasion, they just don't cut it.
Yeah.
And the mining industry, they tend to use our sorts of materials because of wear and abrasion. It's one of the main reasons why they use it. It's when John's talking later on, he'll be talking about flow promotion linings, and that's a pure wear.
Right.
Even things such as conveyor skirts, or what in the mining industry, some people call them hungry boards, which is just on the side of a conveyor, you have bits of plastic that sit on the side of the conveyor to stop coal or any minerals.
I think actually there's an image of that. Yeah.
Yeah. So, look, traditionally polyurethanes and even lower end polyethylenes can be used there, but they wear out quite quickly depending on the conveyor speed. And traditionally, when you have conveyor speeds of maybe 3 to 4 meters per second, those sorts of materials are fine. But when you start getting conveyor speed to get up to maybe 6 meters per second, or even sometimes higher, and mines are trying to increase their production, and conveyor speeds is one way of doing that, then you need higher end materials. Actually, and we've recently developed a material called Tycomp HVM, which has been specifically designed for conveyor skirts, or hungry boards, as the industry calls them, for high-speed conveyor belts. And they can actually withstand, we've had them tested against belts at 6 meters per second, and when traditional polyurethanes or some of our lower materials like high-density polyethylene mainly last a matter of days, those sorts of speeds, we've had this material last years. And so it's, and that's really where we sort of operate. And that's where we come into play when helping the industry. It's not just a matter of supplying a bit of plastic sheet or rod. It's actually providing that advice and solutions as well. And I know that's a bit of a typical thing. Every company says they supply solutions, but that's really where we play, where we can help the industry. We jump in, and if they've got a problem and they want to improve performance or productivity, we'll jump in and have a look to see what we can do there, as far as, and wear is a big thing, as well as chemical resistance, lightweight, and all those other things that go along with engineering plastics.
Well, I feel like you made my question look really good. How is one plastic different than the other? Because your answer was so good that it made me look good. So thank you. Before I let you go, what I was curious about is, does the customer, do you get a chance to walk through that with the customer, or you've been around such a long time. Is Dotmar at a point now where the company is really about people reaching out, we need this, this, and this? I'm sure you got to quote it and all that, but really, there must be a lot of faith put in your company to provide it, so that they're not having to go through all the information that's necessary to make sure they get the right product. I was just curious about this sort of essentially the sales process of providing the right product to them.
Yeah, no, absolutely. Before we even get to quoting and a salesperson providing a price and availability, often what customers need, and this is actually part of what my role is and some of my other colleagues in the business, is before we get to the commercial side and looking to sell product, it's actually going through the design process and helping solve a problem. So if someone has a particular problem, they need to select a material, because if they don't know what material they need, then that's where we'll jump in, have a look at their applications, have a look at their environment, the problems that they're having, and then sit down with them and work through it. A good example, a very simple example, where plastics are used, and we're talking about things like nylons and materials like ertolite, are used as bushers or bearings to replace rolling element bearings, which are in dirty, dusty environments that don't survive because you get dirt and dust into a rolling element bearing. We'll actually work with them and look at the loads and speeds, go away, do some calculations, look at the PV values, the pressure velocity values, and then come up with a material that can handle those sorts of pressures and velocities, but also what sort of press fits and clearances they should be running. We do the same with wire rope sheaves as well. Do some calculations on surface pressure loads, firstly, just to make sure that plastic is going to provide a solution. Because if it's not, then there's no use in providing a quotation. So it really is, that's really the next level. It's not like the old days where people come, would sell a rod of material and say, look, Joe next door used it and it worked for him, so now you can try it.
Yeah.
Because it's a little bit more sophisticated than that these days. And we work in an engineering environment, so we do need to be able to provide that service. But also now going even further, my colleague John will talk about flow promotion linings, but something new that we're launching here at the IMARC show, and we encourage people to come along and have a look at it, is smart polymers. And there's a couple of areas that we're showcasing today. One is actually when materials wear out, the biggest problem is how do you know they're wearing out? And especially in a mine site where equipment can be quite remote, it might be 10, 20 kilometres away from the maintenance depot. How do you know that the component is worn out? And now we're looking at we are putting sensors into material that when they're worn to a certain level, the notification is sent to the appropriate person so they know that the material's either worn out
awesome.
has worn out to a certain level, maybe 50%, 75%. So then they can start planning their maintenance. And that's we've actually got equipment and hardware which is connected to our plastics, and we're referring to them as smart polymers, and they're linked back, using just the telephone system to and a SIM card in the intelligent box, which then notifies the appropriate people that when it's wearing out. Even the next step is going to be even material identification, where we're looking for markers into materials so people can actually identify the material. So if an OEM has bought material and then someone's bought a bit of equipment and replaced the material with a cheaper wear component later on, and then gone back to the OEM and said, your components are wearing out, they can actually scan the material and know if it was their material or not, or if it's been replaced with a cheaper alternative, which is something that comes up for OEMs because they want to be able to supply spares, but also supply the right spares and make sure their equipment continues to work as their customers expect them to. And if components are replaced with cheaper, lower end materials, then that can be a real problem. The industry's changing, and we're moving forward. It's not just about supplying a bit of rod or sheet anymore these days.
Yeah, no, that's very clear. I feel like we, and you clearly enjoy the industry. That's one of the funnest things of this show. I mean, I do a lot of interviews, and some people that they like it, but they're kind of wanting to get home type thing. But you actually seem to enjoy it. It's quite a bit to cover. I'm kind of tempted to keep going, but I think we have to bring John on, or he might just push you out of the way.
Well, I could chew you off all day.
Yeah, thanks a lot, Aldo, for coming on. I hope I don't know if you already discussed it with Dennis. I hope we're getting you back on for more episodes, because especially some of the other industries, I'd love to cover that at some point.
No, absolutely. I would love to have a look at that, see what we can do. So maybe I'll have a chat to Dennis afterwards and see what we can do going forward.
All right. Thank you, sir. We'll bring on John.
Okay.
Talk soon.
Cheers, Jared.
Cheers.
Nice to meet you, buddy.
Good to meet you. Okay, John, welcome.
Good morning, Jared.
Morning. Well, I guess it is morning time there. It's 6:00 here in Vancouver. What time is it in Australia?
We're just on noon, actually. We're just on noon. Yeah.
Australia's really opened up in the last, I guess, about 6 months or so. I probably have my timelines. They're all jumbled together. This is one of the first big, open events, I guess, for Australia. Hey, IMARC.
Yeah. It's been a long time coming. The industry has certainly been calling for it for a long time.
Yeah.
And I think that can probably be seen by the number of people that have attended the IMARC exhibition and the response that we've had to our stand as well, and the information that we've been able to share with those that have come through in the day and a half that it's been opening.
Yeah, and in person. That's so nice.
Indeed, yes.
It's a great way to do things.
No COVID. No COVID.
No COVID. What is your sort of focus? You've got some product lines, I believe, that you sort of, or one specific that you wanted to highlight. Can we touch on that and let's sort of unpack it?
Yeah, sure. So the product that I predict will run with is Matrox, and Matrox is a ultra high molecular weight polyethylene. It's been developed for a special purpose. It's there for bulk materials handling and to reduce flow promotion hang-ups and to increase flowability of materials that might otherwise cause production issues within the mining community in particular. But it's not restricted to mining. It can also be worked into other bulk solids handling industries as well.
So is it, sorry, did I misunderstand? So it's sort of it's a product that things can't essentially get caught on. Is that right?
That's correct. Yeah, that's correct. So traditionally in, let's call the mining industry with bulk solid handling, they might have a steel liner or a ceramic liner, and they've certainly still got their place in the industry. But a lot of the ores that we deal with, and especially the concentrates, are very sticky. You know, you add a little bit of moisture to them and they become cohesive or adhesive, and so they stick to the insides of bins, chutes, hoppers, backs of dump trucks, and so that needs to be shed from that steel substrate. So we fixed this liner to the walls, in essence, a little bit like your Teflon coating in your fry pan, so that your egg doesn't stick. So this is the industry version, the mining industry version of that type of thinking.
So is this an aftermarket install? Like, are mines starting to adopt this in? Oh, I guess I should clarify. How new is this product line? How long have you been delivering it to customers?
Well, the material itself has gone through a number of developments through the years, and I've been dealing with this type of material for about 30 years. I was being involved with the development of this particular grade of material, Matrox, back in 2004, and then really brought it into commercial use in 2007 at a power station down in Victoria, where we installed about 1,000 square meters of this material into a coal delivery hump bunker. And it was a raging success. And so from there, it's just been booming and really going from strength to strength. So it's been a long time coming, but and the development over those years, we've seen more and more people coming into the business. The level of tooling and equipment has also grown, so that we've got toolboxes in each of the states of Australia, so that we can react to the mining industry's demands and requests, because the shutdowns come around very quickly, and we have to react and be able to get to those mines so that we can do the installation ourselves.
So is this ever installed as an OEM with through the OEM or the original manufacturer? Is it, or are you coming onto site and installing? How is this brought onto site?
Yeah,
into use?
Yeah, well, we definitely use both avenues, Jared. So we'll be working in with engineering consultants. So we can start right from the word go, where they're designing the equipment, and then that we might go out to tender for liners, and we'll put together an installation proposal. And once that's been accepted, we can either go to a fabrication shop and fit it to new steel, which was quite a luxury, rather than going to site and having to go through quite a few inductions and deal with site work. But it's something that we're very well versed in. We prepare ourselves well for that. All of our tools and equipment are in order for that specific lining as well. But as you can appreciate, when you're lining into a piece of equipment that's in the field for some time, it's less than ideal. So we've got to deal with some of the peculiarities that we get on site to run with those installs as well. So it might have to be blasted and then painted so that the internal steel substrate is in a acceptable manner or condition that we can fit our Matrox liners to, because it's fitted up with predominantly stud welded. So we need the steel substrate to be in reasonable condition.
So are you, when you talk about, you're putting it out, if let's say it goes out for tender, you put in your bid, are you competing against other just other producers of materials of a similar type of material, or are you competing against someone that's trying to offer a steel liner for this job? Or has the industry sort of accepted this as a superior way of doing it? What's sort of the setup there?
Yeah, Jared, we probably have both challenges. Sometimes it's determined that an ultra high molecular weight polyethylene liner is the way to go. So there are other options out there, and so if that's the case, quite often the end user or maybe the designer might involve a third party testing facility, so they can do
right
shear testing.
We've had them on the show, yeah, that do that kind of testing. Yeah, it's very interesting.
Yeah. So we can do that, or yes, it might be a steel or a ceramic that might be involved, or an air cannon or vibrator, something like that might be introduced.
So you'd be comparing. So in this process, what are some of the materials you'd be sort of comparing, like I guess bidding against, or could be?
Yeah. Well, there's plenty of options out there to the end user, and some of them are passive, like ours, because Matrox doesn't need any energy. Once it's been fitted to the wall, then that's it. It's a set and forget. Whereas there are other options that might be mechanical aids. So there might be air cannons that might be used, or vibrators. So these are obviously needing more energy. So a lot of mine sites are looking to reduce their energy input or usage and try to be more cost effective that way. So we've certainly got an advantage in that regard, because it is passive.
Just from the safety aspect, and I think it's an important, because it's obviously such a key topic on this show, is what is the system of going out and doing an install? Maybe even if you have a case study, but just on a wider scale, what is the process of actually putting a team onto a working mine and installing these liners?
Yeah, it's quite involved, because there are a lot of prequals that need to be ticked off before you even get onto site. So a lot of our work will be done in confined space. So all of our people have to be confined space trained and have current confined space training. It might be working at heights, and the same applies to that, needs to be current. Medicals need to be done so that they've got a base level as to how well you are in both mind, body, and soul, almost, to get onto a site these days. You don't have to be a triathlete by any means, but you certainly have to be in a reasonable shape so that you're not going to put yourself at harm or anybody else at harm. Then there's also the drug and alcohol tests that need to happen. Once all of that's been ticked off, then it might go to the next level, where we then need to do quite a few modules of inductions to get onto sites as well, so that we can be aware of all of the inherent hazards and dangers that might be faced on a particular mine site. And so that's usually quite involved as well. We'll have a checklist of what we might perceive to be within our own control through our own processes, but we need to adhere to process and procedures that are set out by the mine sites as well. But once we're onto the site, then we'll fill out job safety and environmental analysis, so that we're aware of what the hazards might be and the risks of those hazards. Share that with the team so that everybody signs off that they acknowledged what those hazards might be. And then they'll fill out their own personal risk assessments in the form of a Take 5, so that they can look around, see what their particular job is, and make sure that they're fully aware of whatever hazards might be about, and then bring those to the table if we need to adjust the JSDA in any way prior to the work starting. And if anything changes, because it's like a fluid type of arrangement, things happen during the course of a day.
Yeah.
So we might have to get back to the JSEA and then adjust the JSEA, make sure that everybody's on board with that. Equipment needs to be isolated as well, so they'll have an isolation procedure. Each of the individuals, before going into the confined space, will need to lockout, so they have a personal red lock, so that has to go onto the appropriate lock box, so that they know that all of that gear is safe. Nothing's going to get turned on before we're finished and all the bodies are out of that confined space.
So can we kind of go to a project that encompasses everything that we've already talked about? Is there a project that stands out recently that you can sort of walk us through to wrap up?
Yeah, there is. We've just recently gone to a bauxite mine up North Queensland, which is quite a job to get to. We need flights, accommodation, we need ferry transfers, we need to hire vehicles for the site. So getting to the site is quite onerous. And then once you get to the site, there's still pre-quals, as we spoke about before, going through medicals and inductions to get to the site. This was in a beneficiation plant, which is part of the process of refining the bauxite, which will then be turned into alumina and then aluminium. So we had to have crews based on day shift and night shift, and working in with supplementary crews on site that the site had prepared for us as well and provided. We had to have a spotter, and that spotter will look after the people, sign them in and out of the confined space. We needed to line the undersized chute that they provided us, and we've got 6 of these to do. We've done 3 of them now, and it's to replace a ceramic liner that's in place at the moment, which does come away from the wall, falls down into the operating parts of the undersized chute and blocks up pumps and causes all sorts of problems. So we're replacing another material, being ceramic liners, with our Matrox liners, which to date they've had absolutely no problems with at all, and we don't perceive that they will. So we're very happy with that, as is the owner of the mine.
Yeah, I have to say, when I went onto your website, I'm actually on it now throughout this interview, and it's I mean, the amount of products that we could cover, I mean, it is literally, you have to, like, you have so many, you have to do them alphabetically. So yeah, we could cover a lot of topics here. But thanks for coming on, John, and I hope you have a good show. I know you're a very interesting company, a lot of product lines. So I'm glad you're getting out to do a live event like this, because yeah, it was long overdue.
It certainly is, and I thank you for your time too, Jared. Very good. Great working with you.
Thank you, sir.
Cheers.
Cheers. Thank you, everybody, for watching. Again, thank you to Savanna Equipment for getting us all over the world to do these remote mining now episodes. And please join us at the next event that we have coming up. And thank you for Dotmar for being featured on the show. We hope to get them back again, and possibly on some of the other series that we're doing, because they obviously are serving other industries as well. So thank you, everyone. We will see you on the next episode of Mining Now.